So anyways, my name is Michael Anderson. I'm going to shift gears a little bit. I'm going to, so just give you some context. So I'm going to represent DoD as a consumer of open source 5G rather than a contributor to some extent. So the project I'm going to brief is called Okudu. Okudu was started, in theory, about 3 years ago when DoD decided to try to leverage open source for some tactical 5G applications. So the focus of Okudu, as Tom had mentioned, is really security. And to that extent, we're making headway. We've developed an information repository. We've set up some testing capabilities. And I'd like to briefly do a little bit of a public service announcement to talk about terminology, because it's really important, I think, when we're talking about security, that we're talking the same language. So I've heard multiple presentations since I've been here on security, and you'll hear security referred to as, to some extent, code coverage or vulnerability in the code. So the type of security we're worried about within DoD has to do with the end-to-end network. So as part of this kind of little public service announcement, I'd like to just kind of review the security terminology. So initially, right, we talk about vulnerabilities. I think, I imagine most people here have heard of the National Vulnerability Database. So what is a vulnerability? It's really just, it's an assumption that a system will not be violated, right? And there are vulnerabilities in pretty much all of our systems, and there is a big level of trust that we have when we turn on our phones and we connect to a network that we're going to be secure. So a threat is probably the most common terminology that you'll hear when we talk about security. So in terms of a threat is a known attack vector, right? So you've found and you've identified a vulnerability, and I gave an example, right? That you can flood a network and you can actually disrupt the service. So the exploits are what we're really concerned about. So a lot of times you'll hear somebody talk about like a zero-day threat. So is a zero-day threat as important as an exploit? In our opinion, an exploit is the most critical thing that we need to close. So there is something called the Known Exploit Vulnerability Database, which that's really synonymous with, I think, what we call a zero-day threat. And then ultimately the risk. When we talk about risk, there's a couple of factors, and that's the severity of the threat and the likelihood that's going to occur. So the example for that is denial of service attacks, right? That's a known exploit. Sometimes you hear that referred to as a zero-day threat. But I think it's really important for us to have this common language when we're talking about security. All right, so getting back to Okudu. So as you just saw, right, so the government has really gone to great lengths to try to come up with this whole of government approach for 5G. And it's a really unique opportunity, I think, for industry. And I'm going to share the ecosystem that we're setting up to embrace this whole concept of a whole of government 5G approach and how we hope to contribute back to some extent to the open source community. So to start things off, I would like to discuss the actual problem that we're trying to solve with open source. And that is, as you've heard today, it's a lack of secure, trusted 5G for use by DoD and other government agencies. So the purpose, obviously, is to establish this solution using open source software. So why open source software? There are cited needs within the government to have access to source code. I can embellish on that, but for the sake of time, I'll just leave that as a statement. So the way we're trying to do this is through this Okudu project. Okay, so what really are we talking about when we talk about the problem of Okudu? So I have a picture up there on the left-hand side that would be Private Anderson, 18-year-old Private Anderson, who's been given a cell phone. And for whatever reason, Private Anderson has forgotten that his staff sergeant told him not to relay important information, right? So Private Anderson connects to a public network. For whatever reason, his phone does not negotiate encryption, and he's now communicating unencrypted information. And he decides to send important information to a private network, a DoD government network, and he's just passed vital information. That's bad, right? So Private Anderson's going to get non-judicial punishment later. But for the time being, right, we have to figure out a solution to this problem. And So what I demonstrated up there is the advantage of a private network for DoD, which is what we're really looking at for Okudu. So there's a couple problems. I demonstrated the network problem. There's another problem too that is, I think it's a problem. I think depending on who you are, you might consider it to not be as big of a problem. But I do have a question. So how many people here have or have had more than one cell phone at any one time? So that's pretty good. So about half of us, right? So that is a potential physical security problem, in my opinion. So the need for having multiple phones, is there a need? Or is that something that we could potentially solve with the ability to dual SIM a phone on a private and a public network? So one thing we are not doing is looking to enhance the security of commercial solutions. That is, I think, a little bit of a misnomer when we talk about what we're trying to do here. There is, for example, there's DoD and base 5G, and then there is this private tactical 5G. And what we're really talking about is how DoD is trying to establish, a secure private tactical network. So just to make sure that's clear to everybody. Okay, so boundary condition. Oh, my little symbol got messed up there. So apologize for the misprints there. So what we're talking about is limiting this problem to what we can control, right? So obviously an end-to-end solution is a really big, complex problem. What we're focusing on right now is a small segment that we believe we can control with open source. It's also one of the most important parts, which is the CU and the DU. So why are we doing this? The real end goal is to be able to secure it and to improve our ability to mitigate these known exploits or zero-day threats. So SE Linux is, in my opinion, this is just Mike Anderson speaking, is a really good example of how we feel the government can contribute back to the security of an open source solution. So I'm assuming everybody here is familiar with SE Linux. If they're not, that was an effort that was led because the government wanted to improve access control of Linux. So they funded the enhancement of Linux, and it's still currently used by DoD. It's been a very successful effort. Okay, to that end, we released a RFI not long ago on behalf of both DoD and NSF, and we had a really warm response. So it was, in our opinion, it was a very positive request for information. We had a lot of interesting industry response, and it led to a lot of fruitful discussions, and in our hope, continued efforts. Okay, so this is hopefully the interesting slide for everybody here. So I'm going to describe our methodology quickly, and then I'm going to move on to how we're doing security testing. So in this loop, what you see is our stakeholder requirements, because at the end of the day, what we care about is what the government offices or the programs of record or our government partners are willing to fund. So that drives everything we do. So what we have currently established is we've established an information repository that we're going to use to push-pull our security enhanced code from open source CUDU. So what you can't see is the right side bullet going up to the open source CUDU was a dashed line. And the reason for that is we recognize that within the government, we're going to have security enhancements that may or may not be may or may not translate to the open source community. So some of the data will go back. Some of it may be irrelevant. For example, we might have specific security requirements, or we might have platforms that aren't interesting to the open source community. So number 3 is the security testing that we're doing of threats and exploits. So when we start to do tests on behalf of the government, there is, and we take it very seriously in terms of ensuring that reports are confidential. One thing we don't want to do is test a vendor solution, identify what would be considered a security gap or a vulnerability, and then have that information leaked and somehow damage the reputation of that vendor. So we're taking the security testing portion very, very seriously. But then at number 4, this is where we believe there's some opportunity for industry and academia. So through that information repository, we believe we're going to develop some useful AI/ML data sets, and there's, of course, going to be opportunities for vendors to help us enhance security, also to be able to identify known exploits, and loads of academic research. So one of the things that we really do hope to like, why is DoD embracing open source? Outside of the security is we really hope to leverage economies of scale and to be able to establish affordable solutions so that Private Anderson actually has a communications device when he has to go to the field. Okay, so here's our methodology. So what are our inputs, and how are we going to go about doing this testing? So obviously, open source software with security enhancements is, on the left-hand side, is our first input to how we're trying to conduct this security testing. So if you saw the presentation earlier today on OpenSSF, that's a good example of how we're going to hopefully do software composition analysis of whatever open source CUDU software becomes available to us. So once we have that software, we're really limited in what we can test without support from industry. So if Ian's here, Ian, is commercial testing important or not important? I'll answer for him. He won't say it. It's important. So as you heard today, right? So lab testing is really, really important, and that is going to be our first step. We're reliant on industry to help us do that. We can't test something we don't have support from industry currently. So 3GPP obviously deals specifically with authentication, ciphering, integrity. The ORAN has done a really good job with their threat modeling documentation. If anybody's interested in security and they haven't read the ORAN's threat modeling documentation, I strongly encourage you to do so. It's a really good document. And then, on the right-hand side, our other input, which is going to be a series of unique security threats and prioritize threats from industry, academia, and government. So all of those go into our government test bed to do security and regression testing. And ultimately, we do want to end up with over-the-air testing. And that results, obviously, in our stakeholders being able to assess the risk and determine when and if this security is acceptable to deploy in given scenarios. Okay, so this is my last slide. So these are some of the challenges and some of the things that we're trying to figure out how to do, right? So the first is, how do we prioritize threats? So there is obviously recognition that securing 5G from end to end is a really big task. So how do we start? Like, where do we start? So obviously we can start with the known tests from 3GPP. We can start with some from ORAN. How do we go beyond that? How do we prioritize? So I mentioned the National Vulnerability Database. Do we adopt that standard? Do we develop new? Once again, once we prioritize threats, how do we go about mitigating those? This is going to be a big area for, hopefully for the open source community to help us. So I believe that there was a threat that was identified and rapidly closed by the open source community. It was posted on Linux Foundation's webpage. That was a really good example of how we hope to leverage open source. And in the end, probably the most important part is how do we establish a user community. So the goal of the Okudu project is to provide a source of value back to the open source community. And the hope is that by providing something of value to the open source community, there will be contributions and the government will be able to take advantage of those economies of scale. And that concludes my presentation. So thank you very much, Arpit.